Hello there, and welcome to the Sleepy Science Drift. Tonight we'll drift through the quiet ballet of spinning worlds, planets that should have danced in perfect rhythm, yet somehow chose their own pace. Some turn forward, some backward, some lie sideways in eternal twilight. Even the sun, the heart of all, leans as if it's keeping an ancient secret. The solar system, once thought to be a clockwork of symmetry, hums instead with quiet imperfection. And within those small tilts and backward turns lies a deeper story, not of chaos, but of creation. Close your eyes for a moment and imagine the beginning. There was no light, no planet, no sky, only a vast cloud drifting in the dark, a whisper of gas and dust, ancient as time itself. That was how everything began, not with fire, but with stillness. This cloud, what astronomers call the solar nebula, turned slowly in the deep silence of the cosmos. Hydrogen and helium made up most of it, the lightest, simplest elements. Tiny grains of carbon and iron floated among them, the dust of dead stars, the memory of older worlds long gone. Gravity was the first to stir. It drew the cloud inward, pulling every particle toward the invisible center. As it did, the cloud began to spin faster, just as an ice skater spins faster when pulling in their arms. The slow breath of the nebula became motion. In that motion, something beautiful happened. The cloud flattened into a wide, glowing disk, thin as a whisper, vast as eternity. At its heart, the sun ignited, and light returned to the void. Around it, the leftover dust swirled and shimmered, slowly gathering into small knots, tiny worlds in the making. If the universe were a song, this would have been its first measure, the first harmony. Everything moved in one direction, calm and clear. Every newborn planet turned the same way, their paths aligned like dancers circling a single flame. That was how it was meant to be. But nature, it seems, prefers variation to perfection. Somewhere in that early light, the symmetry broke. A collision here, a magnetic whisper there, a ripple of gravity moving through the gas. Tiny, invisible disturbances spread through the disk like notes bending out of tune. Some parts of the nebula thickened, some thinned. One region spun slightly faster, another slower. Over millions of years, those tiny differences became destiny. Each forming world began to turn not quite the same as its neighbor. A small tilt became a signature, a unique rhythm. The solar system was no longer an orchestra playing one melody, but a collection of instruments finding their own timing within it. The harmony did not vanish, it changed shape. The first to take notice of these differences were astronomers with telescopes aimed at the sky. When they measured the planet's spins, they were astonished. Mercury's axis stands almost perfectly upright, tilted by only 1/100th of a degree. Earth, our blue home, leans at 23.5 degrees, and that gentle angle gives us the rhythm of seasons, the reason snow melts, flowers bloom, and shadows wander across the years. Mars tilts a little more, 25 degrees, so its seasons echo ours. But then comes Venus, a world nearly upside down. Its axis tilts 177 and it spins backward, taking 243 Earth days to complete one slow rotation. Uranus, pale and distant, lies almost on its side at 98 degrees, rolling like a sleeping giant across its orbit. Even the Sun, our anchor, is not quite straight. Its axis leans by 7.25 degrees, a subtle defiance. The cosmos, it seems, is not a machine built for order. It is a living rhythm, delicate, uneven, endlessly patient. Scientists call this pattern axial tilt chaos, but perhaps the word chaos is too harsh. Every tilt tells a story. Each strange angle is a fossil of motion, a frozen echo of something that once happened long ago. To understand why the planets spin the way they do, we have to look backward, billions of years, into a time when the solar system was still soft and forming, a time of both creation and quiet violence. when gravity and motion were still learning how to coexist. Gravity, in its simplicity, creates order. It gathers, it shapes, it pulls things toward the center. But motion resists, it spins, it throws outward, it refuses to collapse. The balance between these two forces, falling and spinning, is what made every planet possible. Imagine a small clump of dust orbiting the young sun. It wants to fall inward, but its motion keeps it in orbit. Over time, it gathers more dust, grows heavier, begins to spin faster. That spin becomes its day. Its tilt becomes its individuality. And as more worlds form, their orbits pull on one another, gentle tugs that shift their axes ever so slightly. These are the invisible hands of gravity, not violent, not random, but persistent. The early solar system was not quiet. It was a crowded place, full of fragments colliding, merging, breaking apart again. Some of those collisions were catastrophic. One of them, scientists believe, gave birth to our moon. About 4.5 billion years ago, a young Earth was struck by a body roughly the size of Mars, a world we now call Theia. The impact tore Earth's crust apart, vaporized rock, and threw molten debris into orbit. That debris circled, cooled, and gathered into the sphere we call the moon. It also tilted Earth's axis to the angle we know today. Without that impact, our planet might spin straight and still, without seasons, without the long, slow breath of time that life depends on. From destruction came rhythm. From chaos came balance. Venus, too, carries scars of its own. Some scientists believe it was struck multiple times in its youth, each collision slowing its spin until it finally reversed. Others think its dense atmosphere, the thickest of any rocky planet, acted like a brake, gradually turning it backward through endless friction. Both stories could be true. Both speak of time as the sculptor. Uranus, that sideways wanderer, may have suffered a single massive collision, or perhaps it was nudged gradually by the pull of its distant neighbors, Saturn and Jupiter, over hundreds of millions of years. No matter which path it took, the result is the same. A planet that rolls through space like a dream, its poles facing the sun, its equator lost in shadow. A reminder that even stillness has motion hidden inside it. Every planet holds its own memory of formation. Jupiter, immense and heavy, resisted change. Its sheer mass anchors it upright, its spin barely tilted, its day racing by in less than 10 hours. It is the metronome of the solar system, the deep heartbeat that keeps time for the rest. Saturn, lighter and more graceful, leans softly at 26 degrees, perhaps from a long gravitational dance with Neptune, a slow, patient waltz written in the language of resonance. Mercury, smallest and closest to the Sun, stays nearly upright, its spin locked to its orbit by the star's relentless pull. 3 turns for every 2 orbits, a mathematical rhythm as precise as poetry. The solar system, when seen this way, is not broken. It is simply alive. Each planet is a note, each tilt a tone. The differences between them are not mistakes, they are harmonies in disguise. Scientists once searched for a single rule that could explain every spin, every tilt, every direction of rotation. But perhaps there is no single rule because the universe itself does not repeat. It prefers variation, asymmetry, a soft divergence from the expected. Perfection, after all, is silence. Motion requires imperfection to exist. When we look up at the night sky, it's easy to think of the planets as eternal, unchanging spheres, but they are not fixed. Their axes wobble slowly over ages. Their spins lengthen or shorten by moments too small for human time to notice. Even now, Earth's rotation is slowing, just a fraction of a second per century, as the moon tugs gently at the oceans. Venus's day is lengthening too, its thick air still pressing against its rocky surface. The solar system breathes in time too slow to measure. What we call stability is only balance across billions of years, a stillness so vast that it feels eternal, though it never truly is. And so, when we ask why planets spin the way they do, we are really asking how balance emerges from motion, how order survives within change. It's not just a question of physics, it's a question of patience. The universe does not build perfect machines, it grows living systems. Every orbit, every tilt, every backward spin is a conversation between gravity and time. Some conversations are brief, a single collision that ends in silence. Others last forever, like Saturn and Neptune locked in their invisible dance, or Earth and the Moon circling in quiet partnership. Together, they remind us that nothing in the cosmos is truly still. Even stillness is only motion so slow that it feels like rest. So tonight, as you imagine the planets turning in the dark, the gentle lean of Earth, the slow backward crawl of Venus, the sideways roll of Uranus, think of them not as anomalies, but as variations in a single vast melody. A song written by the laws of motion, performed in silence. Somewhere out there, the sun hums softly, its light spreading across the drifting worlds it created. The planets spin, tilt, and drift, not in rebellion, but in rhythm. And as the Milky Way glows faintly across the night, we find ourselves a part of that rhythm too. Our planet leans, our days turn, our hearts keep time with the same slow, patient beat. The universe breathes, and within its breath, everything moves. In the beginning, there was nothing but drifting light, a slow mist of gas and dust, stretching across space like a sleeping ocean. The universe had already lived many lives by then. Stars had been born, burned, and died, scattering their ashes into the dark. Those ashes became the seed of our solar system. Hydrogen and helium, iron and carbon, silicates and ice. Together they floated, quiet and unformed, waiting for something to begin again. And then, perhaps by chance, a whisper passed through that cloud, a ripple of energy from a nearby star's death, or a gravitational shiver born far away. Whatever it was, it disturbed the calm. The cloud began to collapse under its own weight, and motion returned to the void. As the nebula fell inward, it began to spin. Slowly at first, then faster and faster, its edges curling like a whirlpool. In the center, the pressure rose until hydrogen fused into helium, and a small star awoke, our sun. Around it, the rest of the cloud flattened into a vast, thin disk of dust and vapor, glowing faintly in reflected light. Within that disk, the planets began to form, tiny grains sticking together, merging into pebbles, then stones, then worlds. It was a simple, graceful beginning, governed by a single rule. Everything spins in the same direction. Every orbit, every rotation, born from the same movement. The solar system should have been an eternal mirror of symmetry, but nature rarely keeps its promises. Somewhere in that newborn calm, harmony began to slip away. The disk that seemed smooth was not smooth at all. It rippled and buckled under forces no one could see. Magnetic fields from the young sun reached into the gas and twisted it like invisible fingers. Gravity gathered more strongly in some regions than in others, creating eddies and spirals in the flow. Dust clumped unevenly, the balance tilted. In the language of the cosmos, symmetry is fragile. A single spark, a single push, and the pattern begins to drift. Imagine standing at the edge of that ancient disk, if such a thing could be felt. You would not see color or hear sound, only a slow shimmer in the distance. The light of the sun would scatter through the haze, turning the gas into a sea of gold. Small fragments would pass by like drifting islands, each turning gently, each growing heavier with every orbit. Some would collide, merging into larger bodies. Others would shatter apart. It was not chaos, it was motion finding its rhythm. But as each new world formed, the rhythm changed slightly. the pattern of spins and tilts bending away from perfect order. Harmony was still there, but hidden beneath layers of difference. Scientists call this time the era of planetary formation, a few tens of millions of years when the solar system was young, glowing, and full of change. Within that span, nearly everything we see today took shape. The planet's spins, their tilts, their orbits, all were written then, long before Earth cooled enough for oceans or air. And within that process, one quiet truth emerged. Symmetry cannot last in a living system. Every interaction, no matter how gentle, leaves an imprint, a magnetic pulse, a collision, a gravitational tug. Each alters the angle of motion just enough to make every world unique. The first agent of this change was magnetism. The young sun, though small compared to what it would become, was violent. Its surface boiled with energy, flaring out storms that reached across millions of miles. Those magnetic winds brushed against the surrounding disk, slowing some regions while speeding others. It was like the hand of a painter dragging through wet color, smearing what was once smooth. This process, called magnetic braking, robbed certain zones of their angular momentum, leaving them to drift slower than the rest. The difference created tension. In time, that tension turned into misalignment. Some portions of the disk began to tilt, forming the seeds of what would later become tilted orbits and uneven spins. At the same time, gravity played its own quiet game. The disk was not a uniform sheet. It was full of density waves, ripples caused by slight variations in pressure and mass. Those ripples gathered into spirals like arms of a galaxy, pulling on nearby material and bending their motion. Modern telescopes like ALMA in Chile can see this happening around young stars even today. In those distant systems, we watch bright rings of gas warp and twist, revealing the birth of asymmetry as it once unfolded here. The same physics that gave us order also gave us imperfection. The universe, it seems, cannot create without introducing variety. Over time, the gas thinned and the planets grew. The sun blazed stronger, burning away the mist. Worlds that had once formed quietly began to drift apart, their paths shaped by each other's gravity. Some of them collided, merging into larger planets. Others were hurled outward or inward, trading places like dancers swapping partners. Each collision changed a planet's spin. Some tilted a few degrees, others completely overturned. Venus may have been struck multiple times, its slow backward rotation a lingering memory of those impacts. Uranus might have been hit once by something the size of Earth, flipping it almost completely on its side. Even the sun's small 7 degrees tilt could be a fossil from its birth cluster, a subtle pull from a sibling star that long ago drifted away. When scientists look at the planets now, they see not random differences, but frozen evidence. Each tilt, each rotation, each direction is a clue to an ancient event. Mercury's upright calm, Earth's balanced lean, Jupiter's steady spin, they tell a story of how the early solar system tried to stay in rhythm but could not. The reason is simple. Motion is never isolated. Every world feels the presence of every other. They tug, they trade, they resonate. Gravity, in this way, is like a conversation that never ends. And over time, conversations change those who speak them. There is a beauty in this imperfection. If all planets spun alike, the solar system would be silent, predictable, without contrast. Instead, it moves like a piece of slow music, each note leaning slightly off key, creating depth and texture. Earth's tilt gives it seasons. Mars's wobble brings cycles of ice and dust. Saturn's lean reveals its luminous rings. Venus's backward turn makes its day longer than its year. Even Uranus, rolling sideways, brings something rare, a world where dawn and dusk last 40 years each. In their differences, the planets make the universe interesting. The loss of harmony created meaning. When astronomers run their simulations, giant digital experiments that trace billions of years of motion, they find that even small disturbances can ripple outward into great change. A 1% shift in early rotation, a faint nudge from a passing object, can produce entirely new arrangements of spin. The outcome is never certain. Run the same simulation twice, and the solar system forms differently each time. Some versions produce extra planets, others lose them. In one, Earth might spin faster. In another, it might tilt enough to freeze its poles for eternity. The message is humbling. Our reality is just one version of many possible outcomes. The balance we see now, the gentle 23.5 degree of our axis, the rhythm of our seasons, was not inevitable. It was a quiet accident. But perhaps accident is the wrong word. The universe is not careless. It is creative. It builds through contrast, through small deviations that allow complexity to bloom. Symmetry is sterile. Variation is life. When we look at the tilted planets, we are seeing that principle in motion, the cosmos choosing diversity over perfection. Even in their disarray, the planets remain bound by the same gravitational song. None escapes the sun's pull, none forgets its orbit. The solar system is not broken, it is breathing. The scientists who study these motions often speak in equations, but beneath the numbers lies something almost poetic. Angular momentum, gravitational resonance, magnetic turbulence, all are expressions of relationship. They describe how things respond to one another, how they adjust, how they give and take. If we translated the mathematics into feeling, it might read like this: nothing moves alone. Every spin owes itself to another. Every tilt is the memory of a touch. The cosmos, in that sense, is a tapestry woven not from stars and dust, but from the history of connection. The young solar system, for all its seeming chaos, was not a war, but a conversation of forces. Collisions did not destroy it, they defined it. Even the most violent impact gave birth to something new: the moon, the rings, the atmosphere, the balance of day and night. Over billions of years, these echoes of motion settled into stability. The orbits we see now are calm, the tilts unchanging across human time. It is easy to forget that beneath that calm lies a story of turbulence and fire, like the surface of a lake, smooth only because the waves beneath have balanced each other. Today, telescopes peer into other star systems and find the same asymmetry repeated again and again. Some planets orbit backward around their stars. Others are tilted more than 90 degrees, their poles aimed sideways into the void. Even their suns spin crooked, just like ours. What once seemed a mystery unique to our solar system has revealed itself as universal. The universe prefers imperfection. Every system breaks its symmetry eventually. It is not failure, it is evolution. A pattern of imbalance that allows structure to endure. Perhaps that is the lesson hidden in the science. We expect the universe to favor order, but what it truly favors is resilience. The planets do not fall apart because of their tilts. They persist because of them. The irregularity becomes stability. The variation becomes balance. Earth's seasons, born from its lean, made life possible. Venus's slow spin gave its atmosphere the chance to move energy in strange, complex ways. Uranus's sideways roll created decades of light and dark that sculpted storms. Even the sun's slight tilt may have helped shape the distribution of planets in the first place. Every deviation serves a purpose, though the purpose is not design. It is consequence, and consequence, in a universe without intention, becomes the closest thing to meaning. So when harmony vanished, it did not leave silence. It left a deeper music, one that takes longer to hear. The solar system is a symphony of differences. Its beauty lies not in perfect order, but in the way disorder found balance again. The planets spin at their own tempos, yet none drifts away. Gravity binds them all, not as chains, but as rhythm. It is a reminder that even in the grandest scales of space, harmony is not the absence of difference. It is the relationship between them. And so we drift forward through that realization, through the quiet marvel of a universe that never repeats itself. Each planet's tilt is an act of individuality, a signature written in motion. Each rotation is a heartbeat, steady but never identical. Together they form a cosmic breath. Inhale, exhale, drift, return. The early solar system was not a single perfect chord struck once and forgotten. It was an unfolding melody, still playing, still evolving, still shimmering in the dark. Perhaps that is why the night sky feels alive. When you look at it, you are not seeing stillness. You are seeing memory. Every light is moving, spinning, turning slowly through its story. Somewhere in those distant glows, other worlds are forming, other harmonies breaking, other tilts being written into being. The pattern continues. Order rises, fades, and reforms again. Like the tide, like breath, like time itself. The universe never truly lost its harmony. It simply changed its rhythm. There was a time when the sky was young and violent. The planets we know today were still molten, still soft, their surfaces shifting under seas of fire. The solar system was not yet calm. It was a gallery of collisions, a cosmic storm of creation and destruction. Rocks the size of mountains wandered through space, guided only by gravity's invisible threads. Some struck and shattered, others merged and grew. In that endless exchange of impacts, the worlds found their shapes, their spins, their tilts, their rhythms. All were written in those moments of chaos. From the silence of dust came motion. From violence, order began to breathe. Scientists call that era the Late Heavy Bombardment, a time roughly 4 billion years ago when the planets were still forming and their orbits were not yet steady. Space was full of debris left over from the birth of the sun, fragments of stone and ice drifting like embers in the dark. When gravity called them together, they fell inward, colliding with the new planets again and again. Each strike sent shockwaves across the newborn worlds, tilting them, spinning them, melting their surfaces. If we could stand in that era, we would see the solar system as a field of glowing scars, every planet bearing the mark of 1,000 impacts. It was not peaceful, it was not gentle. Yet from that storm came the stability we now depend on. The moon still carries the memory of that time. Look at its surface through a telescope. The craters, the plains, the scars that never heal. Each one is a frozen moment of impact, a silent explosion preserved by the absence of air or rain. The moon's face is a story written in dust, a record of collisions so frequent that for millions of years, night never truly fell. Earth was struck too, but its atmosphere, oceans, and time have hidden most of the evidence. Only a few ancient basins remain, subtle shadows in the crust that remind us of how it all began. Every crater, every tilt, every broken orbit is a fossil of that forgotten storm. Among those impacts, one stands above the rest, the collision that created the moon. Long before Earth cooled, a body about the size of Mars crossed its path. Scientists named it Theia. The two worlds met in silence, but the silence did not last. The impact melted half the planet, throwing vaporized rock into space. For a brief time, Earth glowed with light brighter than any sun, a molten sphere surrounded by a halo of fire. Slowly, the debris cooled and gathered, forming a companion that has circled us ever since. The moon was born from destruction, yet it became our stabilizer. The same impact that could have ended Earth's story gave it balance instead. It set our planet's axis at 23.5 degrees, granting us seasons, rhythm, and the gentle oscillation of climate that made life possible. The blow that might have been fatal became a breath of order. Venus and Uranus carry their own versions of that memory. Venus spins backward, its day longer than its year, as if time itself reversed direction. Some think a massive collision once flipped it over, inverting its rotation. Others believe smaller, repeated impacts slowly slowed its spin, letting the sun's gravity and atmosphere take over until the planet turned in the opposite way. Uranus, pale and distant, lies on its side, its axis tilted 98 degrees, rolling like a ball around the sun. Simulations suggest a single catastrophic strike could have done it, a glancing blow that toppled the planet without breaking it apart. Or perhaps gravity itself, working over millions of years, twisted Uranus slowly into its current slumber. Both stories are possible, both quiet in their own way. Whether by sudden impact or gradual pull, the result is the same: a planet forever sideways, carrying the stillness of a fallen dancer. Collisions, though fierce, are not random. They follow the rules of physics, as predictable as tides once you see the pattern. When two bodies meet in space, they exchange angular momentum, the invisible quantity that determines how fast and in what direction they spin. The angle of impact, the speed, the size, each decides the outcome. A direct hit can merge two worlds into one. A glancing strike can send one spinning backward. A smaller impact can simply tilt the axis, a whisper instead of a roar. In that sense, every spin in the solar system is a memory of contact, a handshake between worlds that no longer exist. The violence ended, but the motion remains. Jupiter and Mercury, by contrast, escaped most of this chaos. Jupiter's immense gravity drew many projectiles into itself, absorbing their energy without losing its balance. Its mass is so great that even a colossal impact would barely nudge it. It spins fast, one rotation every 10 hours. Its axis tilted just 3 degrees, almost perfectly upright. Mercury, though small, is locked tightly to the Sun. Its proximity makes it stable, its spin captured in resonance. 3 rotations for every 2 orbits. Like a clock ticking in time with its maker, Mercury remains almost untouched. They are the survivors that kept their symmetry while others lost theirs. But even their calmness tells part of the story. Without Jupiter's pull, many of those violent travelers might have struck Earth instead. Our giant neighbor has been a shield as much as a companion. When astronomers model the early solar system, they see the planets moving through an ocean of debris, trading energy with every encounter. They call it a cosmic pinball, but the metaphor misses the subtlety. These impacts weren't merely random collisions, they were acts of balance. Every strike redistributed motion, spreading spin, heat, and energy across the system until an equilibrium emerged. Without them, the planets might still wander in unstable orbits, their spins chaotic. The destruction was not an interruption of creation, it was its method. The universe builds by breaking, then rearranging what remains. Look deeper, and the pattern grows even more poetic. The same collisions that tilted planets also seeded their diversity. When Earth was struck by Theia, the resulting heat melted iron into its core, giving us a magnetic field to shield life. When Mars was bombarded, its crust cracked, forming the vast canyons we see today. When Saturn's moons collided and reformed, their fragments spread into the rings that circle the planet like frozen light. Each scar is a form of beauty, an unintended consequence of motion. The violence ended long ago, but its artistry remains, carved into the orbits, the tilts, and the silent revolutions we watch from below. There's something paradoxical about this. We think of destruction as an end, but in the language of the cosmos, destruction is only transition. When 2 worlds collide, they do not vanish, they transform. Matter changes shape, energy becomes motion, spin becomes memory. What seems like loss becomes pattern. The Earth and Moon are one body divided into 2, forever circling, forever remembering the moment they were the same. Venus, in its slow reverse spin, reminds us that even time can turn backward under the right conditions. Uranus, lying on its side, shows that balance can arise from imbalance. The universe does not fear impact. It uses it as an instrument, tuning its worlds with each collision until the music settles into rhythm. We see echoes of this process far beyond our system. Around other stars, telescopes like Kepler and TESS have found planets with orbits so steeply tilted they almost fall sideways. Some circle backward, others spin in directions opposite to their suns. There is no single pattern, no universal rule. Every system carries its own scars, its own accidents, and yet, across them all, the outcome is the same. Motion continues. Worlds still form, still rotate, still find balance after chaos. It is as if the universe knows how to heal itself, not by returning to perfection, but by discovering stability within imperfection. In that sense, the collisions that shaped our solar system were not acts of cruelty. They were acts of evolution. The Earth that carries oceans and forests is a child of impact. Its rotation, its seasons, even its magnetic field are the echoes of ancient crashes. The moon that steadies our tides was born from one. Without them, there would be no balance, no rhythm, no home for life to arise. When we speak of the violence of the early solar system, we are really speaking of its generosity, the way it traded chaos for possibility. And still, the echoes of that time linger. The planets no longer collide, but they continue to speak to each other through gravity, exchanging energy in quieter ways. Small asteroids still fall now and then, reminders of an age when creation was louder. Meteorites that land on Earth carry within them traces of the earliest materials, fragments older than the planet itself. We hold them in our hands, these ancient stones, and touch the memory of a storm that gave us everything. The calm we live in is the shadow of that chaos, stretched thin across time. When we look at the sky now, it feels peaceful. The planets follow their paths with precision. But if we could watch their history sped up, millions of years passing in seconds, we would see a dance of collisions, rebounds, and transformations. The solar system would look alive, its orbits trembling and realigning, its worlds exchanging momentum like dancers trading hands. From afar, it would look almost deliberate, as if guided by a hidden rhythm. And maybe, in a way, it was. Not guided by will, but by the quiet inevitability of physics, the universe's own kind of patience. The mathematicians describe it with equations. The poets might call it destiny. Both mean the same thing. The universe changes by contact. Every spin, every tilt, every backward turn is proof that even destruction carries design. The energy of impact never disappears. It becomes part of the new whole. A planet turned, a moon born, a season created. When we trace the motion of the planets, we are tracing those moments of transformation. The scars of the past become the structure of the present. And perhaps that is the most comforting truth of all. The universe is not fragile. It can endure collapse, fire, and collision, and still find a way to shine. Our world, our moon, our gentle spin, all of it emerged from that furnace. Out of the noise of broken symmetry came the hum of stability. The planets we see tonight are not the survivors of destruction. They are the children of it. Their rotations are lullabies written by impact. Their tilts the memories of motion. Even in their silence, they turn with purpose. So when you gaze at the night sky, remember that calm was born from chaos. The light of the moon is the reflection of an ancient explosion. The quiet of Earth's orbit is the aftermath of countless storms. Every planet that spins in darkness carries within it the memory of collision, the pulse of what once was fire. And as the universe continues to drift, so do we, moving in the same ancient rhythm, carried by the same invisible forces that shaped the first dawn. The cosmos is not still. It is always remembering. Far beyond the rocky worlds, past the warmth of the sun's direct embrace, two giants drift in slow, silent grandeur. Jupiter and Saturn, twin sentinels of the solar system, one dense and fierce, the other light and adorned with rings. Together, they rule the outer regions like ancient gods, shaping the destinies of all the smaller worlds around them. Their gravity sculpts the paths of comets and asteroids. Their presence steadies the rhythm of the solar system itself. And yet even they carry within their vastness a quiet tilt, a lean that speaks of the same imperfections that define every planet before them. Their balance is not born of stillness, but of immense dynamic grace. If we could hover above Jupiter, we would see a world in constant motion. Its surface is not solid, but a sea of clouds swirling in patterns older than humanity. Storms the size of Earth spin across its face, each one a vortex of hydrogen and helium dancing to the laws of physics. And beneath that swirling atmosphere lies a core of metal and liquid, compressed under unimaginable pressure. Jupiter spins faster than any other planet, one full rotation every 10 hours. That speed flattens it at the poles, widening its equator like a disk in motion. Yet for all its furious rotation, Jupiter's axis tilts only 3 degrees. It stands almost upright, unbothered by the turbulence within. Its immense mass keeps it steady, its gravity anchoring the solar system in a rhythm both fierce and calm. Jupiter's presence is a kind of protection. Its gravity acts as a shield, capturing stray asteroids, diverting comets, absorbing impacts that might otherwise strike the inner planets. Earth owes much of its peace to this distant giant. Without Jupiter's pull, the solar system might have remained a chaotic arena of collisions. Instead, its vastness brings order, like a silent guardian turning violence into orbit. And yet, this stability comes with a paradox. The same gravitational power that shields also shapes. It nudges Mars, bends Saturn, and sends ripples through the fabric of the solar system that never truly fade. Jupiter's upright stance, its relentless spin, is not stillness. It is balance found through motion, a living example of harmony born from force. Saturn, on the other hand, tells a gentler story. It spins quickly too, completing a rotation every 10.5 hours, but its axis leans more, about 26.5 degrees. That tilt gives Saturn seasons, just as Earth's tilt gives us ours. But Saturn's seasons unfold over decades. Each pole basks in sunlight for more than 7 years before sinking into twilight for another 7. The planet's slow dance with the sun stretches time itself, turning the rhythm of light and shadow into something almost eternal. And around it, those rings, thin, fragile, and radiant, like frozen music, made of ice and rock, some pieces as small as dust, others the size of mountains. They orbit in shimmering layers. They are not ancient, they are transient, perhaps no more than 100 million years old. Scientists believe they were born when a moon wandered too close, torn apart by Saturn's gravity. The fragments spread and settled into rings, held by the same forces that destroyed their source. Even here, creation and loss coexist. The rings are both a memorial and a rebirth, the visible echo of motion made gentle. What connects Jupiter and Saturn is not only their scale, but their influence. They are the twin architects of the outer solar system. Their orbits, though vast, are not entirely separate. They resonate with each other. Saturn's year is almost exactly twice as long as Jupiter's. Every 5 of Jupiter's orbits, Saturn completes 2. This ratio is no coincidence. It is resonance, a gravitational rhythm that keeps both planets in a steady dance. If their timing drifted too far, chaos might ripple through the system. But instead, they move in harmony, exchanging small tugs that keep their paths aligned. Scientists call this the Great Resonance. But in simpler words, it is a dance that never ends, a slow waltz of giants moving through space. This resonance has power beyond beauty. It stabilizes the orbits of the outer planets, ensuring that Neptune and Uranus remain in their lanes. It creates patterns in the asteroid belt between Mars and Jupiter, gaps where the resonance's pull has cleared the space entirely. It shapes the rhythm of comets, guiding some inward toward the sun while casting others outward into the cold. The dance of Jupiter and Saturn, though invisible to the naked eye, sets the tempo for everything that orbits near them. They are the metronomes of the solar system, each rotation and revolution echoing through billions of miles of emptiness. Yet for all their control, they are not untouched by imperfection. Jupiter's magnetic field tilts about 10 degrees from its axis, giving its auroras an uneven pulse. Saturn's rings, though symmetrical from afar, are made of billions of pieces, each one following its own slightly different orbit. Even their lean, the subtle angles of their axes, reminds us that nothing in the universe stands perfectly straight. The laws of motion do not favor rigidity, they favor grace. Tilt allows light to move differently across their surfaces, shadow to change, seasons to exist. Without tilt, there would be no variation, no time, no story. The relationship between these giants is ancient, but it may not last forever. Over eons, their gravitational resonance shifts. Saturn's moon Titan pulls gently on its parent planet, changing its tilt by fractions of a degree each century. In distant futures, Saturn's lean may increase further, aligning its rhythm even more closely with Neptune's. Jupiter, too, is not immune. Its moons, Io and Europa among them, tug at its spin, shaping the way its gravity breathes through the solar system. Motion never truly settles. It evolves, softly but ceaselessly. Scientists study these changes through equations and simulations, tracing how gravity transfers momentum across space. They call it angular momentum exchange, but beneath the math is a truth far simpler and far older. Every movement in the cosmos affects every other. Jupiter cannot turn without Saturn feeling its pull. Saturn cannot lean without Jupiter's orbit shifting ever so slightly. Their bond is not just gravitational, it is relational, the physics of companionship. They have shaped each other for billions of years, a cosmic friendship written in gravity and time. When viewed from a distance, their connection feels almost human, two immense beings sharing the same silence, influencing one another without ever colliding. Their separation is vast, hundreds of millions of miles, but the space between them is filled with interaction. Every wave of gravity that leaves Jupiter passes through Saturn's rings. Every tug Saturn exerts travels back, changing Jupiter's path by an infinitesimal fraction. It is communication at the slowest possible speed, measured not in seconds, but in millennia. The universe speaks quietly, but it never stops speaking. If we think of the solar system as a great cosmic organism, then Jupiter and Saturn are its lungs, drawing in and exhaling motion, keeping everything in rhythm. They regulate the heartbeat of the sun's domain, maintaining balance through the give and take of gravity. And though they seem distant and cold, they are among the most dynamic bodies in existence. Their winds reach speeds faster than sound. Their storms can last for centuries. Their cores burn with pressures we cannot imagine. They are not frozen giants. They are living systems, each breath made of motion and light. There is a lesson hidden within their enormity. Jupiter's stability shows the strength of mass, the way sheer presence can calm a system. Saturn's elegance shows the beauty of fragility, the way a delicate balance of forces can create something breathtaking. Together, they reveal that strength and grace are not opposites, but partners. The universe, through them, demonstrates that harmony is not found in uniformity, but in resonance. Two different bodies, two different tilts, bound by one rhythm. A reminder that difference, when balanced, becomes music. Even their contrasts tell a story of balance. Jupiter's color is deep, rich, turbulent, bands of red and brown swirling endlessly. Saturn's palette is soft and golden, its clouds stretched smooth by gentle winds. Jupiter's storms are loud and visible. Saturn's are quieter, buried beneath layers of haze. One is solid in dominance, the other subtle in its beauty. Yet both are shaped by the same physics, moved by the same star. Their diversity is not dissonance, it is harmony expressed in multiple voices. If the solar system were a song, Jupiter would be the drumbeat and Saturn the melody, two notes blending into a single, endless chord. Around them, their moons add complexity to this composition. Jupiter's Galilean moons, Io, Europa, Ganymede, and Callisto, move in resonance with each other, each orbiting in patterns that repeat with mathematical precision. Io's volcanic breath, Europa's icy ocean, Ganymede's magnetic heart, all are shaped by Jupiter's pull. Saturn's moons do the same. Titan with its methane lakes, Enceladus with its geysers of ice. Each moon dances to its planet's gravity, each motion feeding back into the larger system. These layers of resonance ripple outward like waves on a pond, extending the influence of the giants far beyond their own orbits. Sometimes, when we watch Saturn through a telescope or see images of Jupiter's swirling storms, we forget that they are moving in perfect precision. The chaos we see is organized. The storms that rage are bound by equations that have held for billions of years. Even the great red spot on Jupiter, older than any human civilization, spins because the planet's rotation and temperature gradients allow it to persist. Nothing is random. The storms endure because the balance beneath them never breaks. And yet what makes them truly awe-inspiring is not their perfection, but their endurance through imperfection. Their tilts are not the same. Their spins are not synchronized. Their rings, their storms, their moons, all move at different tempos. But together, they sustain a harmony so vast that it holds the entire solar system in rhythm. Perhaps that is what the universe always intends. Not uniformity, but coexistence. A balance in which every motion, no matter how small, contributes to the greater whole. When you look at them from Earth through the thin veil of our atmosphere, they appear as two bright points wandering slowly across the night sky. Sometimes they come close enough that they almost touch, a conjunction that happens once every 20 years. Astronomers call it the Great Conjunction, a moment when Jupiter and Saturn align from our perspective, glowing side by side in the twilight. To the human eye, it looks like a single star, brighter than all the rest. But it is not one, it is two, united by perspective, divided by distance, a perfect symbol for the harmony they represent. And when they drift apart again, their paths diverge, but never truly separate. The pull between them continues, invisible and constant, like the connection between melody and rhythm, between thought and breath. They remind us that balance does not mean stillness, it means motion held in relationship. They lean, they spin, they orbit, and through all of it, they remain bound. In their quiet companionship, the solar system finds its steadiness. So as you picture them tonight, Jupiter, vast and unshaken, Saturn, luminous and leaning, remember that even the grandest worlds must move together to find peace. Their gravity hums through space, carrying with it the lesson written into every atom. Harmony is not the absence of difference, but the gentle rhythm between them. The giants continue their waltz in silence, and the universe keeps time to their steps. Far out in the frozen reaches of the solar system drifts a world that does not quite follow the rules. It spins like a sleeper rolling in bed, its poles pointing almost directly toward the sun. Its days and nights are not measured in hours, but in decades. For half of its long year, one hemisphere is bathed in sunlight that never sets, while the other lies in endless twilight. This world is Uranus, pale, quiet, strange. It does not shine with the storms of Jupiter or the golden rings of Saturn. It hums instead with the stillness of distance, the calm of isolation. And yet within that silence lies one of the most mysterious tilts in the universe, a planet that chose to lie sideways while the rest continued upright. Astronomers call Uranus an ice giant, but the term is misleading. Beneath its soft blue color lies not solid ice, but layers of gas and fluid, a vast ocean of water, methane, and ammonia that never truly freezes. Its clouds form in shades of turquoise, a reflection of sunlight scattered through methane in the upper atmosphere. To the eye, it appears calm, but that calm is an illusion. Deep within, currents move slowly, silently, carrying heat and momentum in ways we still barely understand. Uranus is cold on the surface, colder than any planet except Neptune, but its story burns with hidden energy, the memory of a tilt so dramatic that it reshaped everything about it. We do not yet know exactly how Uranus came to rest on its side. For decades, the most popular idea was a collision, a massive impact during the solar system's youth, when planets were still jostling for place. A world perhaps as large as Earth might have struck Uranus at a glancing angle, knocking it over without destroying it. Such a blow would have tilted its axis nearly 98 degrees, sending its spin sideways. The debris from that collision might even have formed its faint rings and small moons. But newer theories offer a gentler story. Some scientists now think Uranus might have leaned slowly over millions of years as the gravitational pull of Jupiter and Saturn tugged on its orbit, twisting it ever so slightly each cycle until the planet lay flat. In either case, by violence or by time, the result is the same: a world that rolls instead of spins, caught forever between extremes. When Voyager 2 flew past Uranus in 1986, it revealed a planet both familiar and alien. No great storms marked its surface. No vivid clouds or bands broke its smooth appearance. It seemed almost asleep, featureless, subdued. But that stillness may not be emptiness. It may be balance. Uranus rotates once every 17 hours, fast enough to create winds that circle the planet at nearly 900 kilometers per hour. Yet from a distance, those winds leave no trace. The planet hides its motion beneath its own symmetry. There's a kind of poetry in that, turbulence disguised as calm, movement invisible to the eye. Because of its extreme tilt, Uranus experiences seasons unlike any other world. Each pole spends 42 years in daylight, then 42 years in darkness. When summer finally arrives in one hemisphere, sunlight shines directly down on it, while the other hemisphere turns its back entirely to the sun. It is as if the planet breathes in light and exhales shadow in the slowest rhythm imaginable. These long seasons may drive subtle changes in its atmosphere, currents that reverse direction, layers of clouds that rise and fall like tides over centuries. To live there would be to exist within time stretched thin, where the cycle of day and night feels more like a heartbeat than a clock. The moons of Uranus share this strange orientation. Their orbits lie along the same tilted plane, circling the planet's equator instead of the plane of the solar system. That means they too rise and set sideways, forever turning over their horizon. Each moon is small and pale, named after characters from Shakespeare: Miranda, Ariel, Umbriel, Titania, and Oberon. Miranda is perhaps the most mysterious, its surface marked by cliffs and ridges that seem stitched together from pieces of other worlds. Some believe it once shattered completely and reassembled under gravity's pull. Like its parent planet, it carries the scars of disruption turned into beauty. If we could stand on one of those moons during Uranus's long solstice, we would see a sight no other planet could offer. The sun would hover motionless at the horizon, neither rising nor setting, casting a perpetual glow across the ringed sky. Uranus itself would loom enormous, pale blue and half-shadowed, rolling slowly in space. The rings, faint but wide, would cut across the darkness like threads of glass. Time would seem to hold its breath. And perhaps that is what Uranus teaches us, that stillness is not the absence of movement, but a form of motion stretched beyond our human perception. For scientists, Uranus remains a puzzle. Its magnetic field is as strange as its tilt, not centered within the planet, but offset by thousands of kilometers and tilted 60 degrees from the rotation axis. That means the field lines twist and wobble as the planet turns, creating auroras that flicker unpredictably across its poles and equator alike. No other world's magnetism behaves quite this way. It suggests that Uranus's internal layers, its ocean of water and ammonia, circulate in complex, uneven patterns, perhaps forming multiple dynamos instead of a single core-driven one. This crooked magnetism gives the planet a restless soul, an invisible movement beneath its serene exterior. In 2023, when astronomers revisited Voyager's data using modern tools, they discovered faint whispers in the magnetic readings, echoes that might have been the signatures of plasma escaping from Uranus's atmosphere. It hinted that the planet's magnetic field occasionally opens and closes, releasing energy into space like a slow exhale. The same mechanism that drives auroras on Earth may occur there too, only stretched across decades. Even in its solitude, Uranus interacts with the solar wind, responding to the sun's breath across billions of kilometers. Connection persists, no matter the distance. The rings of Uranus, though faint, tell another story of subtle tension. They are dark, narrow, and composed of particles coated in organic material. Some scientists think they were formed from moons ground down by collisions, others that they are remnants of the original impact that tilted the planet. Unlike Saturn's luminous rings, Uranus's are quiet, almost hidden, like whispers instead of song. But their presence reminds us that even worlds that seem empty carry traces of relationship, the remnants of what once was. In their orbiting dust lies history, the slow decay of what was broken, turned into something enduring. Every so often, as Uranus moves through its long orbit, sunlight strikes its poles directly, flooding the upper atmosphere with warmth. During those brief decades, astronomers have seen changes, clouds forming, winds shifting, a hint of awakening. Perhaps the planet is not as dormant as it seems. Perhaps its calm is seasonal, its silence part of a greater rhythm too long for us to perceive. To watch Uranus is to watch patience itself, to see motion so gradual that it becomes indistinguishable from peace. There is something deeply human in the mystery of Uranus. It reminds us that even when change happens too slowly to notice, it still happens. The planet's tilt did not erase its balance, it redefined it. The same forces that once threatened to destroy it gave it a new identity. Its sideways spin is not a flaw, it is a memory of transformation. Every rotation it makes, every slow season of light and dark, carries the echo of the event that remade it. In that way, Uranus is like all of us, shaped by the impacts of the past, yet still moving forward, still finding rhythm within what once was chaos. When we look beyond the science, the numbers, the angles, the temperatures, we find something gentle hidden in the mechanics. Uranus's tilt is an act of surrender. It shows what happens when resistance gives way to gravity, when a planet allows itself to be guided by the forces around it instead of standing alone. It found its peace not by staying upright, but by yielding. And perhaps that is why it feels so serene now, because it no longer struggles against its motion. It rolls softly, endlessly, following a path that balances what it was with what it became. The poet in us might see Uranus as a symbol of quiet resilience. The scientist in us sees it as a key to understanding how planets evolve. Both views are true. Its tilt, its rings, its moons, all are clues in a cosmic story that stretches beyond comprehension. Every orbit of Uranus is a slow lesson in patience, the idea that even the strangest paths can lead to stability, and even the most unlikely orientations can endure. The planet lies sideways, yes, but it continues to turn, to hold its moons, to hum through the void. In the grand order of the solar system, Uranus seems distant, disconnected from the warmth of the inner worlds. But its very distance allows it to exist as it does, untouched by the sun's turbulence. Its sideways tilt does not isolate it. It defines its uniqueness. In a universe that prizes variation, Uranus stands as a quiet masterpiece, a reminder that beauty often hides in the unexpected. The cosmos does not repeat itself. Every planet finds its own equilibrium, its own voice, its own way of turning through time. Imagine now, drifting slowly above that world. The sun glows low on the horizon, casting a dim turquoise light across the cloud tops. Far below, currents twist invisibly through a sea of cold gas. The rings glimmer faintly, their shadows tracing lines across the atmosphere. The silence is complete, but it is not empty. It hums with depth, with memory. You can almost feel the slow rotation beneath you, the gentle roll that defines the planet's soul. It turns not upright, not aligned, but perfectly itself. And as you drift away, watching Uranus fade into the darkness, you might sense the larger truth it carries, that there is grace in leaning, in changing, in not standing the way others do. That even in the vast silence of space, individuality is not chaos. It is harmony expressed in another form. The planets do not all follow the same pattern, just as no two lives unfold alike. Yet each finds its rhythm. Each learns to move in peace with its history. Uranus, the sideways world, whispers this softly through the dark. Balance is not sameness, it is acceptance. And through that acceptance, even a tilted planet can find serenity. Venus turns so slowly that its day outlasts its year. A single sunrise takes 117 Earth days to arrive, and when it does, the sun rises not in the east, but in the west. The planet spins backward, a solitary dancer moving against the current of the cosmic waltz. To watch it from afar is to witness defiance in motion, a world choosing its own rhythm, unhurried, deliberate, eternal. But in truth, Venus is not defiant at all. It is patient. Its strange rotation is not rebellion. It is the result of quiet forces, subtle and continuous, shaping a planet over eons until it turned the opposite way from where it began. From Earth, Venus shines as the brightest light in the dawn or twilight sky. Ancient observers called it the morning star and the evening star, never realizing they were seeing the same world. It has always been a symbol of beauty and calm, a soft glow that follows the horizon. But up close, that beauty hides intensity. Beneath the pale clouds lies a surface of searing heat and pressure. 900 degrees Fahrenheit, enough to melt lead. An atmosphere thick enough to crush steel. The air is made almost entirely of carbon dioxide, cloaked in sulfuric acid mist. The light that reaches the ground is dim and golden, filtered through haze. It is a world of stillness and fire, a paradox suspended between grace and destruction. Venus once may have been much more like Earth. Billions of years ago, it might have had oceans, clouds of water, even rain. But the sun's growing warmth changed everything. As temperatures rose, water vapor filled the atmosphere. Water, though gentle, is a powerful greenhouse gas. It trapped more heat, which evaporated more water, which trapped even more. The feedback loop spiraled until every drop of liquid vanished into the sky and the oceans boiled away. Without water to dissolve and bury carbon dioxide, the gas accumulated. The planet's surface grew hotter, its skies heavier, until the world entered a kind of perpetual fever. The air itself became a monument to time, a reminder that even beauty can transform beyond recognition. This transformation also changed the planet's motion. Venus spins backward now, but it almost certainly didn't start that way. In the early solar system, it likely rotated in the same direction as most other planets, turning swiftly in the same rhythm as its orbit. Something must have happened to slow it, stop it, and then reverse it. For years, astronomers imagined a great collision, another young world striking Venus, flipping it over like a coin. The impact theory made sense at first. After all, Uranus and Earth had been reshaped by collisions. But over time, a different idea took root, one that speaks more of subtlety than of violence. Venus, it seems, may have turned itself backward. Its atmosphere, dense, turbulent, and massive, plays a role unlike any other in the solar system. The winds on Venus move faster than the planet itself, circling the globe every 4 days, driving immense waves of pressure and heat across the upper layers. This difference between air and surface creates a constant exchange of torque. Over millions of years, those winds, coupled with the pull of the sun's gravity, may have acted like hands on a spinning wheel, gradually slowing the planet's rotation until it stopped, and then gently turning it the other way. A process so slow, so delicate, that no single moment marks the reversal. Just the quiet accumulation of force until direction itself changes. In this sense, Venus is the embodiment of patience. Its motion tells us that transformation does not always come from collision or chaos. Sometimes it comes from persistence, small, steady influences adding up over unimaginable time. The very air, heated by sunlight, pushing softly against the surface again and again until the planet's heart turns. There is a kind of tenderness in that thought, a reminder that the universe does not always shape through violence, but also through endurance. The backward rotation of Venus has another consequence. It makes its day unimaginably long. A single rotation takes 243 Earth days, while its year lasts only 225. That means a day on Venus is longer than its year. The sun rises in the west, climbs slowly through the golden haze, and sets in the east months later. Between those two events, the sky glows in perpetual twilight. The planet's slow spin also means that its shape is almost perfectly spherical. Centrifugal force barely affects it. It moves like a dream suspended in amber, drifting through the sun's light in near silence. For scientists, Venus is both a mystery and a warning. Its thick atmosphere traps heat so efficiently that it has become a natural laboratory for the greenhouse effect taken to extremes. Studying it helps us understand how fragile Earth's own balance is, how easily climate can tip into new states if feedback loops go unchecked. Yet to view Venus only as a warning is to miss its deeper beauty. It is also a testament to resilience. Despite the crushing pressure and searing heat, the planet maintains order. Its winds move in perfect layers, its clouds form in repeating bands, its atmosphere circulates with precision. Within its chaos is structure, a balance found in the very forces that seem most destructive. The planet's slow rotation affects everything about it. Without a strong spin, it lacks the kind of magnetic field that protects Earth from solar radiation. Instead, its upper atmosphere interacts directly with the solar wind, forming a long, flowing tail that stretches far behind it in space. Like a comet, Venus leaves a faint trail of charged particles in its wake, invisible to the eye but detectable by instruments. Even here, we see the planet's quiet dialogue with the sun, a constant exchange of energy between light and matter, between the giver of heat and the world that holds it too tightly. Venus's surface, though hidden by clouds, has been mapped by radar. What it reveals is hauntingly complex. Mountains higher than Everest, plains of solidified lava, vast plateaus that once may have flowed like rivers of rock. Some regions show signs of volcanic activity, suggesting that the planet is not geologically dead but only sleeping. The crust appears young, as if it has been renewed in the recent past, perhaps through massive resurfacing events where molten rock once covered the globe before cooling again. Even beneath its stillness, Venus carries the pulse of change. The combination of its slow spin and dense air means that winds at the surface move only a few kilometers per hour, gentle enough to barely disturb a grain of sand. Yet above the clouds, the winds race at hurricane speeds. Two worlds coexist within one, a tranquil surface below and a furious atmosphere above. It is a striking metaphor for contrast, the calm that hides beneath movement, and the movement that sustains calm. Venus is both storm and silence, both rage and peace, a reminder that opposites are not enemies, but partners in the balance of existence. There is another quiet wonder about Venus, the way it resonates with Earth. The two worlds are almost the same size, made of the same materials, born from the same cloud of gas and dust. Their orbits are close, their masses nearly identical, and yet one became a cradle for life, while the other turned into a furnace. When viewed from the perspective of cosmic time, the difference is fragile. A few degrees, a few molecules, a few decisions of chemistry. Perhaps that is the lesson hidden in Venus's story, that balance is delicate and beauty can exist even where life cannot. The planet is a mirror of what might have been, an alternate reflection of Earth's destiny. When we observe Venus now through telescopes or through orbiting spacecraft, we are looking into the past of possibility. We are seeing what happens when a world leans just slightly too far toward heat, when atmosphere and light conspire to create eternity out of stillness. But we are also witnessing something graceful, a planet that even in its extremity moves with perfect consistency. Its backward rotation, its steady orbit, its endless cycles of cloud and wind, they all unfold in quiet precision. Venus has found peace within its imbalance. To think of Venus is to think of time itself slowed down. A sunrise that takes months, a day that lasts nearly a year. Yet the planet does not seem impatient. It moves at its own pace, unconcerned with the speed of others. Perhaps it knows something we forget, that there is no race in the cosmos, only rhythm. Each world turns as it must, shaped by its own story. The universe does not demand synchronization. It allows difference, and in that difference, it finds harmony. When sunlight touches Venus, most of it is reflected away by the clouds, scattering into space. That is why it shines so brightly in our sky, because it gives back more light than it receives. It reflects rather than absorbs. There is poetry in that, a world so harsh yet luminous, so closed yet radiant. From Earth, it appears serene, its brightness a beacon in the darkness. We see the reflection, not the storm beneath. And maybe that, too, is a lesson. Even a world of fire can appear as light to those who watch from afar. Venus reminds us that motion is not always straightforward, that progress is not always forward. Sometimes, to evolve, a system must slow down, stop, and even reverse. The planet's backward spin is not a flaw in nature's design. It is part of the greater geometry of the cosmos, where every motion has its countermotion, every direction its mirror. Just as tides rise and fall, just as hearts beat and rest, so too do planets find their own cycles of reversal and renewal. In the quiet of the universe, Venus turns slowly, endlessly, against the flow. Its rotation hums like a slow heartbeat in the background of creation. Each turn is a reminder that even when everything else moves one way, there is meaning in moving differently. Its winds whisper through the sulfur clouds, its mountains glow faintly beneath perpetual haze, and through it all, the planet keeps its rhythm. It is not a rebel, it is a philosopher, teaching through example that serenity can exist even in extremes. So when you next see Venus shining in the evening or dawn, remember the story behind that light. Beneath the glow is a world that learned to move backward, not through force, but through endurance. A world that once may have been like ours, now transformed into something wholly its own. It turns not in defiance, but in grace. It reflects what it cannot keep, and it moves at the pace of patience. The universe, it seems, values every rhythm, even the ones that flow in reverse. The earth spins gently beneath a sky of blue and silence. Every sunrise, every falling tide, every turning season, each is the breath of a planet that moves with quiet precision. Our world's rotation feels so natural that we rarely think about it. We trust that the sun will rise, that the shadows will lengthen, that night will always return. But this graceful rhythm is not a coincidence. It is the product of balance, of countless forces that once collided, merged, and finally found harmony. The Earth, in its spinning, tells the story of a universe that learned to settle after chaos. Long ago, our planet spun faster. Days were only 5 or 6 hours long, and the surface was molten, wrapped in haze. Then came the impact that changed everything. The collision with Theia, a world the size of Mars. The force was unimaginable. It tore the Earth apart, melting rock, flinging vaporized debris into orbit. From that glowing storm, the moon was born. The two bodies, the Earth and its child, have been locked in an invisible embrace ever since, circling one another through the quiet dark. It was that collision, that single act of violence, that gave Earth its tilt, its seasons, and its rhythm. Out of destruction came balance. Out of impact came time. The moon became a stabilizer. Its gravity pulls gently on Earth's equator, holding our axis steady at about 23.5 degrees. Without that pull, Earth would wobble wildly over millennia, its poles swinging like a spinning top about to fall. Some planets, like Mars, live without such an anchor. Their axes drift through vast angles, tipping climates into chaos. But Earth, bound to its companion, remains calm. The moon's slow tug lengthens our days a little each century, by mere milliseconds, invisible to human life but immense across ages. Someday, billions of years from now, Earth's rotation will slow enough that one side will always face the moon. They will stand still, relative to each other, a silent pair frozen in eternal gaze, balance perfected through stillness. The moon's influence is written in the tides, the pulse of the oceans breathing in rhythm with the sky. Twice each day, the sea rises to meet the air, then retreats again, following the moon as it travels. Every wave that curls and falls, every whisper of surf against stone, is part of that vast conversation between Earth and its satellite. The tides are the sound of gravity turned into motion. They are the heartbeat of connection. Long before humans measured time, the ocean already knew its hours. The water remembered the pull of the moon and responded with the patience of eternity. If the moon vanished, everything would change. Our days would shorten, the winds would howl with new ferocity, climates would wander in patterns no longer predictable. The stability that made life possible would unravel. The gentle seasons that guide the migrations of animals, the blooming of plants, the balance of heat and cold, all of it would drift into uncertainty. The moon does not merely illuminate our nights, it steadies our existence. It is the quiet guardian of rhythm, and beyond it, the sun leans, just slightly, by about 7 degrees. Even the heart of our solar system is not perfectly upright. Its rotation tilts, perhaps a relic of an ancient gravitational tug, perhaps the ghost of a lost twin star that once shared its cradle. That small lean ripples outward, shaping the alignment of the planets, influencing the dust and plasma that swirl around it. Nothing in the cosmos stands exactly straight. Every axis bends a little toward memory, a little toward time. This universal tilt connects everything: the sun, the planets, the moons, the very atoms that spin within our bodies. Perfection in nature does not mean stillness. It means dynamic equilibrium, the ability to remain whole while moving. Every planet, every orbit, every rotation is a conversation between motion and balance. Earth, with its tilt and its moon, represents the middle ground between chaos and calm, between rigidity and freedom. We live not because our world stands still, but because it dances. The moon's creation gave us more than stability. It gave us rhythm. The length of our day, the pace of our tides, the turning of our climate, even the cycles of biological life, all are rooted in that celestial partnership. The earliest life on Earth likely evolved in tidal pools, where the ocean's breathing mixed nutrients and light in regular intervals. Later, the tilt of the planet introduced seasons, guiding migrations and growth, shaping evolution itself. Every living thing on Earth carries, in its rhythms, the echo of the moon's pull. Our own sleep cycles, our body's patterns of light and darkness, are distant biological reflections of a gravitational dance 4.5 billion years old. When we gaze up at the moon, we are not just looking at light. We are looking at history. Its scars, the craters and basins, are fossils of collisions that once filled the sky. It carries the memory of impacts that Earth escaped. Its silence is ancient, but its influence is ongoing. Even now, the moon's gravity drags on the oceans, slowing our planet's spin, lengthening the measure of each day. That drag is the soundless mechanism by which time itself stretches. The days we live are a little longer than those of our ancestors. Each generation turns a little more slowly toward the dawn. Scientists have measured that lengthening precisely, about 1.7 milliseconds per century. It is almost nothing, and yet it is everything. Over billions of years, those milliseconds add up to hours, reshaping the rhythm of the planet. The cosmos changes not with explosions, but with persistence. The same patience that turned Venus backward, that tilted Uranus, now turns Earth gently toward stillness. The universe teaches through slowness. It does not hurry toward perfection. It drifts there. And through that slow drift, harmony emerges. Every spin, every orbit, every gravitational exchange is a negotiation of energy, a balance of giving and receiving. The sun gives light. The planets reflect it. The moon pulls on Earth. Earth pulls back. Even light itself bends slightly when it passes through gravity, acknowledging the presence of other bodies. Nothing moves alone. The cosmos breathes as one. It is humbling to realize that even our daily life depends on these invisible ties. When the sun rises each morning, it does so because the Earth spins. When the seasons change, they do so because the axis leans. When the ocean moves, it does so because the moon whispers to it through space. And when we breathe, we do so within that same rhythm. The air in our lungs has been pulled by tides, warmed by sunlight, and cooled by shadow. To live is to move within this cosmic choreography, to be part of a dance too vast to see, but simple enough to feel. Our ancestors understood this instinctively. Long before astronomy, they followed the moon to measure time. They saw the tides rise and fall and built calendars from its phases. They learned to plant by its light, to travel by its reflection, to honor its pull as sacred. They saw in its cycles the mirror of their own lives: birth, fullness, decline, renewal. The moon was not just a light, it was a teacher, a reminder that even in darkness, something always returns. Perhaps the greatest truth the moon offers is this: that connection sustains stability. Earth and moon are not separate. They are halves of a single story. Their motions are entwined, their destinies shared. Without one, the other would lose meaning. The same could be said of every planet and its companions, of every star and its gravity, of every atom and its orbiting electrons. The universe holds together through relationships. It is not a machine, but a symphony, each note vibrating because of the others. Even now, the system continues to evolve. The moon drifts away from us by about 4 centimeters every year, its orbit widening as Earth's rotation slows. Millions of years from now, The total solar eclipses we marvel at today will no longer happen. The moon will appear smaller in the sky, unable to cover the sun completely. Our nights will grow darker, our tides gentler. The rhythm will change, but it will not stop. Nature's constancy lies not in repetition, but in transformation. When we step back and look at the solar system as a whole, we see this same truth reflected everywhere. Every planet bears the mark of imbalance turned into grace. Mercury, locked in resonance with the sun. Venus, spinning backward in surrender. Earth, leaning gently toward its moon. Mars, wobbling in search of equilibrium. Jupiter and Saturn, keeping the rhythm for all. Uranus, lying sideways in patience. Neptune, humming quietly at the edge, following the faint pull of distant forces. And the sun itself, leaning, turning, breathing light into all. Each world imperfect, and yet together, perfectly alive. The cosmos, in its vastness, is not a static sculpture, but a living rhythm, an endless dance of tilts, orbits, and exchanges. To understand it is to recognize that imperfection is not failure. It is the essence of balance. The sun tilts, the planets lean, the moons pull, and somehow everything holds. In their differences lies stability, in their motion, peace. The same is true for us. We too live slightly tilted, slightly off-center, finding harmony not in control, but in adaptation. And so, when night falls and you look up at the moon, think of what it means. That gentle light crossing the sky is the echo of an ancient impact, the memory of chaos turned to rhythm. It is the reflection of sunlight from a world that steadies our own. Every glimmer on its surface is a reminder that balance is not given, it is found, and that everything, no matter how distant, contributes to the stillness we feel beneath the stars. The universe breathes, and we breathe with it. Every heartbeat is an orbit. Every moment of stillness is rotation slowed into awareness. The earth turns, the moon pulls, and we move together, carried by forces older than time. And if this quiet journey through the cosmos has brought you a sense of peace, if the rhythm of planets and stars has softened your thoughts, then stay a while longer with us. Drift again through the gentle stories of the universe. Let its science become lullaby, its motion become meditation. Subscribe to Sleepy Science Drift, and together we'll keep exploring this vast, tender cosmos, where every spin, every tilt, and every beam of light reminds us. We are part of a universe that never stops moving and never stops breathing.